At 12.3 in our chapter 12 overview, and these are going to cover problems 15 through 21. And in these, we're looking at limits once again, but we're isolating it, looking only at one side of it. So in this first problem, we're giving kind of a Frankenstein um, little function here where it's, if we look at the function, we can see that if I'm approaching it from the left or from values that are smaller than -2, we could see that we're approaching the y value of -3. We could see that if we plug in the actual value of -2, we actually get -2 for our y. And as we're approaching from larger values, approaching -2 for x, we're approaching the y value of -1. So we can see the limit does not exist as an entire function, so we're going to isolate from both sides of that. So looking at this first one, we're looking at values smaller than it. So if you look here, it says x is less than. So we're only looking at this part for the first part, a. That's what this little negative up here means. It doesn't have to do anything with the value. It's just letting us know we're looking at values that are smaller than -2. And this is another way of looking at that. And we're looking at this notation here, x is less than -2. Those are both saying the same thing, and they are both saying the y value is -3. So there aren't any calculations here. It's just getting you used to looking at what does this negative sign mean in terms of finding a limit. Now we're going to look at the second part, and then we see that that value is changed, or not value, I'm sorry, but this symbol is changed. And now instead of a negative, it's a positive, and this means that we want values greater than -2, or x is greater than -2. So we're isolating it and only looking here. Here we do have to do a calculation. So here I do plug in a -2, and I do that and I get -1. So the limit as x is approaching -2 from the right, and that's how that is read. That's what we get. Moving on to number 16. Here we're doing the same thing. Now, a lot of these things you can plug it into your calculator and look at the graph and see what is happening to the left of -1, or I just pick a value. I picked a value that's smaller than -1. I picked -2. When that happens and I plug it in, I get the square root of a negative number, which means that the limit does not exist. And if I have plugged in a number and got something else, then we'd have to do more investigating to see if it's approaching the same value from both sides. Here we're given in number 17, we're given a graph to look at. So you'll be doing this on your own with some of these questions. You'll have to plug it into your calculator. And here we're doing something different. We're not approaching one single value. It's the idea that what is happening, and we're looking at end behavior. And we've done that. You've done it in Algebra 2. We did a little bit in Chapter 8 and also in last semester of looking at end behavior. So you're going to be seeing some of the same techniques we've used before. And so if we plug in, and we're approaching basically a very large number, so 5 times, a billion or whatever the number divided, and we're adding a number that's being divided by a very large number. So we have a huge number and we're adding a small number. Still, it's going towards what's positive infinity. So this is the first time we're really looking at something that's more about ideas and end behavior and what's happening at the end of these graphs. And then number 18. Same thing here, we're approaching positive infinity, so it's like what is happening at the end of it. So here's an example where you have to put this into your calculator to see what's happening. And we see that this is an example where something is going to kind of plateau. It's going to reach some type of ceiling or floor, depending on which way it's going. And we can also look at this as a horizontal asymptote, which we've looked at before, and you'll see in the next couple problems. And so same thing here, we're putting this into y equals. You're going to have to create a bigger window for yourself so we can look at what's happening way out here. I just decided to change my x max to 10,000. You could have made it 100,000. It doesn't matter. Here we do second trace. Same thing we've done before. We're finding the value. I put in a number that's a little bit less than this. If I put in 10,000, it'll just say error. If I put that in, the y value that it gives me is 1.998, which is rounded up to 2. So we can, therefore, that's what these 3 dots are, therefore the limit as x approaches infinity for this function is 2. And then looking at 19. And here's what I was talking about, top, bottom, and equally heavy. So we can look at this because wherever there's a horizontal asymptote, that's creating a barrier for this function. So we can see that these are equally heavy because x to the first power is the same as x to the first power. And then we find that by equaling it to the ratio of those coefficients. So this one becomes 8/9. Or if you're like, man, I don't remember all that stuff, you just simply approach this problem like the one before, and you just graph it into your calculator, and then you would just investigate what is happening on the ends of this. So you may have to change your window. Number 20 is an example of bottom heavy. And so when we have a bottom heavy, so we have x to the first over x to the second, so this has a higher exponent on the bottom, and this is automatically y equal to 0 for a horizontal asymptote. Therefore, our limit is also 0. And then in this last one, it can be done in lots of ways. I just kind of put one way to look at it. We can graph it again like we did earlier and just plug in a very large value. And then we can see, we're just worried about, we're not concerned about the value as much as we are concerned about, are we approaching positive or negative infinity? Because if this means we have an oblique asymptote, which means we have some type of gradient or some type of slope. So it's got to be going up or it's going down. So in this case, I plugged in this large number. I see I get a positive number. And then I know that it's approaching positive infinity. And then that was it.